Hello, we're going to introduce the study of anatomy by tackling several questions. Firstly, the definition of anatomy, and then we'll say a few words about the history of anatomy. Then we'll look at the different branches of anatomy. We'll also look at the various anatomical techniques, without which anatomical progress would not have been possible. As far as definitions are concerned, anatomy, in fact from the Greek anatomia, is made up of two parts, the word ana and the word tomi. Ana means body and tomi means to cut, which means that, ultimately, the word anatomy can be defined as being the science that studies the body by cutting it up or dissecting it to see what it is made of and to learn about the organization of its various constituent parts. Patchett defined anatomy as the science that studies the constitution of organized beings, and Rouvier defined anatomy as the science of the structures of the body. D. Ribet gave an even more exact definition, defining anatomy as the science that studies the form, relationships and final structure of the organs of organized beings, including mankind. Why should you study anatomy? Anatomy should absolutely be regarded as the only solid foundation for the entire medical art. In fact, it is of considerable practical interest. Anatomy is the basis not only for the study of physiology, but also for clinical and surgical techniques. It is a science that makes a considerable contribution, not only to doctors and surgeons, but also to artists, biologists, physiologists and anthropologists. And without studying anatomy, we cannot expect to understand the other sciences on which all medical studies are based. Anatomy is in fact made up of several branches. If you open any anatomy book and look at any chapter, you will see several titles. We'll see what we call descriptive anatomy and topographical anatomy, functional anatomy, microscopic anatomy, developmental anatomy, and so there are several branches and each branch of anatomy deserves a definition. Descriptive anatomy is the description of an organ isolated from the rest of the body. If we take the heart, for example, to talk about its descriptive anatomy is to isolate it completely from the rest of the body. So we're going to take it out of the thorax, put it on a table and describe it in terms of its external configuration, its internal configuration. In other words, we're going to talk about its color, its shape, its consistency, but also the cavities that make it up. So, in the end, it comes down to studying an organ in complete isolation from the body. Topographical anatomy, on the other hand, refers to the study of the relationships between the different organs. If we take the heart as an example, to study its topographical anatomy is to study its relationships, to name the different organs located on the left, the different organs located on the right, above, below, in front and behind. And this topographical anatomy is the basic study of surgery. Another branch of anatomy is functional anatomy, which, as its name suggests, is the branch of anatomy that studies the function of an organ, or the physiology of an organ, the functional anatomy of the hand, for example, separated from the different possible movements of the hand, whether at wrist level, with pronation and supination, or at finger level, or gripping. Another branch of anatomy is medical surgical or applied anatomy. It is the study of anatomy, but with an emphasis on surgical or medical applications. This means emphasizing, with the description of anatomy, all its interests in terms of surgery, but also in terms of diseases, different pathologies. There is also what is known as comparative anatomy, which is anatomy that compares the anatomy of human beings with that of other animal species. For example, here you can see the human skull and the skull of a monkey. Comparative anatomy is all about comparing the different dimensions, shapes. There is also what is known as developmental anatomy. This is the branch of anatomy that studies morphological transformations from fertilization to adulthood. So it encompasses several stages, starting with embryology, which is the first phase of development inside the uterus, and then photology. But developmental anatomy also encompasses postnatal growth, and under this term developmental anatomy, it also includes what is known as teratology, the study of congenital malformations linked to one phase or another of a developmental anomaly. This is also what is referred to as pathological anatomy. Pathological anatomy is the study of the various macroscopic and microscopic alterations that can occur in an organ, such as what you see here in the photo. There is also what is known as microscopic anatomy. Microscopic anatomy, in fact, encompasses the study of cells, cytology, the different cells of the organism and tissues. This is what we call histology. The other branch of anatomy is radiological anatomy. This is in fact the study of the morphology of the body from the outside, but also from the inside, using different radiological techniques, whether standard X-rays, CT scans, MRI or other. Here, for example, is a magnificent sagittal MRI section that shows the different anatomical structures perfectly. There is also what is known as surface anatomy or artistic anatomy, which studies shapes from the outside, providing certain ideal aesthetic parameters. It is of particular interest to sculptors, engravers and painters, as well as aesthetic surgeons. We'll now move on to another interesting chapter, the history and evolution of anatomy. In fact, the first anatomical descriptions date back to 3000 BC, and around 400 BC lived what is considered to be the father of medicine, Hippocrates, who revolutionized medicine in ancient Greece. In fact, he distinguished medicine from other fields, making it independent of other areas of knowledge such as philosophy. And he made it a profession in its own right. Hippocrates was also the founder of ethical rules for doctors. He established what is known as the Hippocratic Oath, which is read by all doctors just before they obtain their doctorate. Another figure who left his mark on the history of anatomy was Aristotle, the founder of comparative anatomy. It was described earlier as the anatomy that identifies the anatomical differences between two species, and Aristotle was the first to use the term Anatom, which we defined earlier. So Claudius Galenus is also a scientist, a well-known anatomist who made a lot of progress thanks to his work on the monkey. And he banned cadaveric dissection for religious reasons. He studied the monkey, publishing more than 500 scientific works. From the 10th to the 13th century, Muslims played a key role in the development of medicine in general and anatomy in particular. A number of Muslim scholars contributed to this development through their writings. For example, Ibn al-Haytham, also Avicenna, who used corpses from the battlefields to dissect them and wrote his famous Canon of Medicine, and Ibn Nafis. They are illustrious Muslim scholars who left their mark through their writings and their groundbreaking scientific and anatomical work. We then witnessed the evolution of things during the Renaissance of the 15th and 16th centuries, with the work of a number of scientists, notably Jacques Dubois, who described the middle cerebral artery, and André Vesale, who is known for having carried out the first public dissection. So it was thanks to him that we started what are known as anatomy lessons, as you can see here in the image above and below. After Vesalius, then, came a succession of scholars who passed on their anatomical knowledge by performing dissections directly in front of students, thus demonstrating the different anatomical structures and their relationships. Anatomy, of course, continued to evolve in the 17th century thanks to several anatomists, Harvey, Malpighi and Peckett. Harvey demonstrated pulmonary circulation, Malpighi discovered capillary vessels and Peckett demonstrated lymphatic circulation. The 18th century saw the birth of physiology, the development of comparative anatomy, the birth of anthropology and the development of biology, as well as the foundation of pathological anatomy by Morgagni. The 19th century brought a great deal to anatomy, in particular with the discovery and use of formalin as a fixative, which was a great help in preserving bodies and therefore in studying anatomy. And another discovery of great value was the discovery of X-rays, which finally made it possible to study bodies without opening them. Of course, this has developed subsequently, through the evolution of imaging in general. At this point of time, anatomy, as we said earlier, is becoming mainly applied. In other words, there is a greater tendency to teach anatomy that is of interest from a medical, surgical or imaging point of view. It's an anatomy that has benefited from the development of imaging, but also of computer tools. In 1993, for example, we saw a project set up by the Americans called the Human Visible Project. It's a virtual man in 3 dimensions that makes it possible to see and study real human anatomy. This project was carried out after the dissection of a death row inmate, who was of course executed, frozen and then cut into 1,800 thin strips. These different strips were photographed at high resolution, creating a very large anatomical database that is extremely useful and accurate. The evolution has been towards the manufacture of anatomical models that faithfully reproduce real anatomy. So, we have several types, with enlargements of the various organs to give a very faithful reproduction of the anatomy with its finest details. This was followed by the launch and development of a number of software packages that enable valuable virtual dissections to be carried out. Several software packages are currently on the market, including Visible Body, which is very well designed and is used here at our faculty. We also saw the creation and marketing of the virtual dissection table, which does not replace the body, but is a very useful tool for teaching anatomy, so it allows virtual dissections to be carried out. These tables can be used to cut bodies in different directions. They also allow us to play on the transparency of tissues and therefore to carry out virtual dissections to show the different structures and even to cut post-mortem photographs in all directions and show the structures from surface to depth, which is extremely important. It can be done either in a small group or in the lecture theatre by projecting the images in front of the students. In a way, it is a good replacement for cadaveric dissection, which is sometimes repulsive for a new student. The virtual dissection tables on the market can also be used to study radiological anatomy. Here at the faculty, we have a cyber anatomy table that we use for tutorials and practical work to teach anatomy through virtual dissections. There are also what are known as synthetic cadavers. These are bodies made of structures which resemble real tissue to a certain extent. In fact, we have some here at the Faculty of Sindeva which we use mainly to teach myology. They are extremely useful, especially for chapters on myology and the anatomy of the musculoskeletal system. It's true that it can also pass on certain knowledge about the layout of different organs, and we also use it for practical sessions on other systems. Now we come to another chapter, that of the methods of exploring and preserving bodies in anatomy. All these developments that we have seen, that is to say, knowledge in general in anatomy is made possible by the exploration of the body, and the exploration of the body can only be done by the conservation of bodies. We are therefore going to talk about the different means of exploration. How can we study a human body so that we can then draw figures, take photos? And how do we preserve it so that we can use it and reuse it or keep it preserved until it can be used? Well, the method that has enabled us to evolve and make things evolve is, of course, dissection. Anatomy has already been defined as the science of studying the body by cutting it up, in other words dissecting it. And here we see an anatomical dissection room where different human bodies are laid out with students or researchers working on a given anatomical region to study its components and describe it. Several scientific research projects can be carried out on different regions, and this is what has enabled anatomy to evolve and produce high-quality scientific work. For example, here we see a dissected anatomical specimen. This is a very good image showing the different muscles, for example of the forearm, or here a dissection of the thorax showing the heart with the pericardium and supracardiac vessels. So we prepare dissection pieces precisely to convey messages to students, but also to carry out scientific research. Of course, the human body can also be explored through surgery, which we could call vivisection, by performing a surgical operation. We can of course pass on certain knowledge of anatomy, showing structures in vivo, such as the cartilages of the wing of the nose, which can be seen and described perfectly well intraoperatively. The other way of exploring the body is through imaging. Thanks to the development of various radiological techniques, we have been able to study the human body without opening it up. As we said earlier, here we see a sagittal section of the cephalic extremity. Imaging enables us to identify the various details and components of the body. This has been made possible by the extraordinary progress made in radiology. These include CT scans, MRIs, arteriography, intravenous urography. What is also interesting and has made it possible to explore the body is endoscopy. Endoscopy involves inserting a camera through a hollow organ such as the esophagus, stomach, intestines, bronchi, to study and describe it from the inside. So after mentioning the different techniques for studying the body, you need to know that the body can only be studied once it has been preserved. And there are different techniques for preserving bodies. The first is embalming. As we said earlier when we looked at the history of anatomy, the development of body preservation has been a great help. We talked about the discovery of formalin. In fact, to preserve a body, in other words to avoid putrefaction and deterioration of the body, liquid preparations have to be passed inside the body's vessels to empty it of blood and inject products that prevent deterioration and decomposition of the body. The bodies are then placed in tanks with formalin and a whole range of products to prevent them from deteriorating. Here we see embryos and foetuses. Aren't they preserved in jars with formalin? The other way of preserving bodies is by freezing them. There are cold rooms at -20 degrees where bodies can be stored until they can be used again. They can also be placed in refrigerators at +4 degrees for short-term storage. Another very interesting technique was developed in 1977, plastination, which preserves biological tissues by replacing the various body fluids with silicone. Look at what this technique produces. It's a body, not a model. It's a real body that has been preserved using a method known as plastination, which, as you can see in this image, enables us to present the human anatomy in a way that is durable, precise, clear and pleasant to look at, precisely by placing the bodies in a normal position, in a position close to life. It's a technique that was invented by a German anatomist, and it's so beautiful to look at, so well done. Even if it's very time-consuming, it takes a lot of time to prepare the bodies so cleanly. Well, after this preparation, the anatomists who have adopted this technique have put on exhibitions all over the world. This is known as the Body One exhibition. It's true that ethically it's debatable, but in any case the result is impressive. The fact that bodies can be preserved in different positions. We can dissect them, keeping only what we want to show as an anatomical structure, after draining them of all biological fluids and replacing them with silicone. Take a look. There is even a horse here that has been preserved by this plastination method. This horse is, of course, being ridden by a body. Who knows that himself has been preserved by plastination? So that brings us to the end of this introduction. So far we've seen the definition of anatomy, the different branches of anatomy. We've talked a little about the history of anatomy and then about conservation and the different techniques for studying anatomy. We're now going to look at how anatomy is taught. Anatomy is such a big science, so the amount of time spent on it is significant. It is so important that it can only be taught in several parts. So in the first year, we'll cover Anatomy 1 in the first part and Anatomy 2 in the second part. Then in the second year, we'll look at Anatomy 3, which is neuroanatomy, and Anatomy 4, which is head and neck anatomy. In the first part of the course, we will cover Anatomy 1, in which we will deal with the anatomy of the musculoskeletal system, the anatomy of the respiratory system and the anatomy of the cardiovascular system. Teaching will consist of both lectures and tutorials. Before going into the general anatomy course, you should know that anatomy is a subject that poses many problems for students. In fact, it's the medical student's pet peeve, and remains one of the most difficult subjects. And why is that? Because it contains a lot of new vocabulary and requires a considerable effort to memorize. So, if you want to succeed and prepare well, you need to follow certain advice and work in a certain way. And that's what we'll be looking at in the next session. How do you do it and what tools do you need to succeed in anatomy?